Hi, this is Jeff Hamrick again with the Financial Analysis Program at the University of San Francisco. I want to take a couple of minutes to show you how to compute probabilities as well as critical thresholds associated with a student t-distribution. So the command in Stata is basically the same as normal and inverse normal, except the names now are t-tail and inverse t-tail. There is one major difference, though, that I want to point out. So when we type in this command, display t-tail, of course, the student t-distribution, unlike the standard normal distribution, we need to feed it a number of degrees of freedom, Stata, so that it understands what kind of t-distribution it's computing probabilities for. And so the first argument that we're going to put in here is actually a number of degrees of freedom. So suppose that we're talking about a student t-distribution with 14 degrees of freedom. And suppose that we're running a hypothesis test, and the test statistic for that hypothesis test, which has a student t-distribution, is, let's say, 2.1. Then this is actually the command that we need in Stata to compute a probability of interest. But this probability is different than the probability we were looking up with the normal command. The normal distribution command in Stata reads from the left. That is, it reads from minus infinity up to a particular point. So t-tail in Stata adopts a slightly different convention. It reads from the right. So this probability we're looking at here is actually the probability from plus infinity on down to the point 2.1 for a student t-distribution with 14 degrees of freedom. So that isn't very much probability. It's about 2.7% of the probability mass, but you're not reading from the left anymore, and that's the main thing you need to keep in mind when you're working with the t-tail function. If you are trying to compute what we have been calling in class a two-tailed p-value, that is, if you're taking the probability in the tail and doubling it before comparing it to the critical threshold of alpha as part of some hypothesis test, you need to modify this statement slightly. You need to go on ahead and put in yourself the multiplication by 2. So you'll need to do something like 2 times t-tail, 14 and 2.1. And that will give you just twice 2.7% or 5.4%. But that's how you can get a two-tailed probability in Stata for a student t-distribution. The reason that works, of course, is because the student t-distribution is symmetric about 0. Notice, of course, that if you have a negative student t statistic, so if I come in and I say, display for me the probability under a student t-distribution with 18 degrees of freedom at the point minus 1.8, what this is actually going to do is sweep out the probability from plus infinity all the way on down to minus 1.8 past 0. So now we're going to get values that are considerably above 1/2, because half the probability underneath the student t-distribution is to the right of 0, and we've asked for the probability to the right of minus 1.8. Okay? So the inverse t-tail function in Stata works with exactly the same conventions in mind. If I type display and I do inverse t-tail, once again, the first thing I need to do is specify a number of degrees of freedom. So let's say that's 122 degrees of freedom. If I want the critical value that leaves, let's say, 2.5% probability in the right tail, which is what I would want for a confidence interval, a 95% confidence interval, this is the command that I need. So that's very close to the 1.96 that we were getting when we were doing normal probability calculations. But once again, the point here is that we're leaving 2.5% probability mass in the upper right tail, and 1.9795999 is the point on the x-axis that leaves 2.5% probability to the right. Okay? If you wanted to explicitly look up a negative threshold, the threshold on the left side of the y-axis, there are two ways you could do that. The first way is the simplest way. Because the student t-distribution is symmetric, you could simply say, oh, well, what I need is minus 1.97. The other thing you could do, however, is you could look up the value that leaves 97.5% of the probability to the right of that value. That will leave, of course, 2.5% of the probability to the left of that value. But you'll notice that the answer here is just the opposite in sign from the most recent answer that we got in Stata. So this is how you use Stata to compute probabilities connected with a student t-distribution, and how you look up critical values under a student t-distribution that you might need for hypothesis testing if you're using the rejection region approach, or if you're trying to get critical values for a confidence interval where the estimator has a student t-distribution. So that's it for now.